Azure Functions is a serverless compute service that enables you to run event-driven code without having to explicitly provision or manage infrastructure. It allows developers to focus on building and deploying apps without worrying about the underlying hardware. Azure Functions can be triggered by various events, such as HTTP requests, timers, or messages from other Azure services. This flexibility makes it a powerful tool for building scalable and efficient cloud solutions. Azure Functions offers several benefits, including automatic scaling, cost efficiency, and ease of integration with other Azure services. Automatic scaling ensures that your functions can handle varying loads without manual intervention. Cost efficiency is achieved through a pay-per-execution model, meaning you only pay for the compute resources used during function execution. Additionally, Azure Functions seamlessly integrates with other Azure services like Azure Storage, Event Hubs, and Service Bus, enabling you to build comprehensive cloud solutions. Before creating an Azure Functions app, you need to set up your development environment. This involves installing the Azure Functions core tools, which provide a local development experience, and the Azure CLI for managing your Azure resources. You will also need an integrated development environment, IDE, like Visual Studio Code, which offers extensions for Azure Functions development. Once your environment is set up, you can start creating and testing your functions locally before deploying them to Azure. To create an Azure Functions app, you can use the Azure Portal, Azure CLI, or Visual Studio Code. In the Azure Portal, navigate to the Create a Resource section and select Function App. Fill in the required details, such as the subscription, resource group, and function app name. Choose a runtime stack, such as .NET, Node.js, or Python, and select a region. Finally, configure the hosting options and monitoring settings before creating the function app. This process sets up the necessary infrastructure for your functions. Application settings in Azure Functions allow you to manage configuration values that your functions can use at runtime. These settings include environment variables, connection strings, and other configuration data. You can configure application settings through the Azure Portal, Azure CLI, or by using a local settings file during development. It's important to securely manage sensitive information, such as API keys and database connection strings, by using Azure Key Vault or other secure storage solutions. Once your function app is created, you can start developing your first function. In Visual Studio Code, use the Azure Functions extension to create a new function. Choose a trigger type, such as HTTP, timer, or blob storage, and provide the necessary details. Write the function code to handle the trigger event and perform the desired actions. For example, an HTTP-triggered function might process incoming requests and return a response, while a timer-triggered function could perform scheduled tasks. Testing and debugging your functions locally is a crucial step before deploying them to Azure. The Azure Functions core tools provide a local runtime environment that simulates the Azure Functions runtime. This allows you to run and test your functions on your local machine. Use breakpoints and debugging features in your IDE to troubleshoot issues and ensure your functions behave as expected. Local testing helps identify and resolve problems early in the development process, saving time and effort. After testing your functions locally, you can deploy them to Azure. There are several deployment methods available, including using the Azure Portal, Azure CLI, or continuous integration and continuous deployment (CI/CD) pipelines. In Visual Studio Code, you can use the Azure Functions extension to deploy your function app directly to Azure. Ensure that your application settings and dependencies are correctly configured in the Azure environment. Once deployed, your functions are ready to handle production workloads. Monitoring and logging are essential for maintaining the health and performance of your Azure Functions app. Azure provides built-in monitoring and logging capabilities through Azure Monitor and Application Insights. These tools allow you to track function execution, monitor performance metrics, and diagnose issues. Set up alerts to notify you of critical events, such as function failures or performance degradation. Regularly review logs and metrics to ensure your functions are running smoothly and efficiently. Azure Functions automatically scales based on demand, but there are additional strategies to optimize performance. Implementing best practices such as minimizing cold starts, optimizing code, and managing dependencies can improve function performance. Use the premium plan or dedicated app service plan for more control over scaling and performance. Additionally, consider using durable functions for long-running workflows and stateful operations. Regularly review and optimize your functions to ensure they meet performance and scalability requirements. Security is a critical aspect of developing and deploying Azure functions. Follow best practices to secure your functions, such as using managed identities for authentication, encrypting sensitive data, and implementing network security controls. Use Azure Key Vault to manage secrets and credentials securely. Regularly update your function app and dependencies to address security vulnerabilities. Implement role-based access control, RBAC, to restrict access to your function app and resources. Ensuring robust security measures helps protect your functions and data from potential threats. Azure Functions offers advanced features and integrations that enhance its capabilities. Durable functions enable you to write stateful workflows using code, making it easier to manage complex orchestrations. Bindings and triggers allow seamless integration with various Azure services, such as Cosmos DB, Event Grid, and Service Bus. Explore custom handlers to extend the functionality of Azure Functions with custom runtimes. Leveraging these advanced features and integrations can help you build more powerful and flexible cloud solutions. Azure Functions is used in various real-world scenarios, from simple automation tasks to complex cloud applications. For example, you can use Azure Functions to process data from IoT devices, automate workflows, or build serverless APIs. In e-commerce, functions can handle order processing and inventory management. In finance, they can process transactions and generate reports. Understanding these use cases helps you see the practical applications of Azure Functions and how they can benefit your projects. While working with Azure Functions, you may encounter common issues such as deployment failures, runtime errors, or performance bottlenecks. Use Azure Monitor and Application Insights to diagnose and troubleshoot these issues. Check logs for detailed error messages and stack traces. Ensure your application settings and dependencies are correctly configured. Review documentation and community forums for solutions to common problems. Proactively addressing issues helps maintain the reliability and performance of your Azure Functions app. Creating and configuring an Azure Functions app involves several steps, from setting up your development environment to deploying and monitoring your functions. By following best practices and leveraging Azure's tools and services, you can build scalable, efficient, and secure serverless applications. Continue exploring Azure Functions by experimenting with different triggers, bindings, and advanced features. Stay updated with the latest developments and best practices in serverless computing to enhance your skills and build innovative cloud solutions.